You accidentally forget your favorite party balloon outside in the Alaskan winter with the temperature of negative 20 degrees Celsius. When you go out to get it again, the temperature drops to negative 40 degrees Celsius. To your misery, the balloon has shrunken. Being the scientist that you are, you know that the balloon had 2.5 liters of gas in it. Can you figure out why it has shrunk and what its new volume is? So let's go ahead and answer this first question. Why did it shrink? So we know that the relationship between temperature and volume is a direct variation. That means that when temperature increases, so does volume. But in this problem, temperature decreased. So when temperature decreases, volume decreases. And so since volume decreased, the gas inside of the balloon doesn't take up as much space, and the balloon therefore got smaller. That's why your favorite party balloon has gotten smaller. But we want to know what this new volume is because, we're great scientists. So in order to do that, we're going to have to use Charles' law. So in order to find the new volume, we need to plug it into this equation, which is known as Charles' law. V1 over temperature 1 equals V2 over T2. Now, V1 stands for the original volume, and T1 stands for the original temperature. And your new volume would be represented as V2, and your new temperature would be T2. Now, in this problem, we're looking for the new volume. So that means that we're going to solve for V2. So in order to solve for this, we need to be able to plug in the values and isolate or separate this variable from the rest of it. So in order to plug this in, we need to go to the information that we have in our problem. So we know that the original volume was 2.5 liters. So we'll put that on top and replace V1 with that. Now the first temperature would be negative 20 degrees Celsius. But in order for us to use temperature in this equation, we have to keep it in units of Kelvin rather than Celsius. So in order to do that, we just add 273 to our temperature in Celsius, which gives us 253. So you just replace T1 with that. Now remember, we're looking for V2, so we just leave that there. And then T2 would be negative 40 degrees Celsius, but again, we have to convert it to kelvins, so that would be another 273 plus negative 40 equals 233. So there's our equation. Now, we have to be able to solve this and separate this variable from the rest of it so that we know what that equals. So in order to solve for V2, like I said, we have to separate it. So the first step in doing that would be cross multiplication, which means that we just multiply the units that are diagonal from each other. So that would mean 2.5 liters times 233 Kelvin equal V2 times 253 Kelvin. Now, if we were to solve this, we have to divide both sides by 253 because we want to isolate this variable. So if we were to do that, our new equation would be 2.5 liters times 233K over 253 Kelvin, which equals V2. And so that equals 2.30 approximately liters. And so that's how much gas is in your balloon.